for the lesson. So, product rule, it's fairly basic. Once you identify the product rule applies. So, it's the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first. Now the question would be, how do we know when the product rule applies? The answer to that is if there's a product of two factors. Right? So in this case, I have two factors that are being multiplied. Very easy to identify that the product rule would be in play here. Although I would say that you don't necessarily have to use the product rule because you could just distribute this out and then find the derivative after the fact, right? However, there will be plenty of situations where you won't be able to do that and you'll have to use the product rule, so you won't have a choice. All right, so once you identify the first function, now the first function is the one that actually comes first, so it's easy enough. So here's my first, and here's my second. I'm going to take my first function and multiply it by the derivative of the second function, then add to that the second function multiplied by the derivative of the first. So the first function, as is just 6x plus 5. The derivative of my second function is going to be what? 3x squared. Plus my second function, x cubed minus 3, times the derivative of my first function, which is what? 6. All right. Now, it just says differentiate, so I'm done. It didn't say differentiate and simplify. It just said differentiate. Differentiate, slope of the tangent line, derivative, instantaneous rate of change, they all mean the same thing. All right? So
what would simplify be? Like, what other step would you have?
you'd have to distribute, combine like terms, so all algebra 2 stuff. So in that particular instance, you didn't really have to do this technique because you could, like I said, you could have distributed it out initially, but we opted to do it because we've got to start somewhere. Now in the second case, you don't have a choice. All right, so g of x, I'm going to rewrite my function. Instead of the root of x, I'm going to write it as x to the 1/2 power times the sine of x. That multiplication is telling me that it's a product, and the product rule is in play. All right, so I need g prime of x, which again is the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first. All right, so the first function as is, x to the 1/2. Derivative of my second function, cosine of x. Second function as is, sine of x, multiplied by the derivative of the first function, which is what? Exactly. 1/2 x to the negative 1/2. All right. In this case, there's really not much you could do. I mean, the best you could do would be maybe make that x to the negative 1/2 into a denominator, you know, but it wouldn't advance the cause, so I would just kind of leave it at that. Yeah. The last one, again, first function, identify your first function and your second function that are being multiplied. All right, product rule only works if you're dealing with a product of two factors. All right, so again, first multiplied by the derivative of the second plus the second multiplied by the derivative of the first. All right, so what do we got? Times negative sine x, cosine x, cosine x. All right. Now this one also did not tell us to simplify, but you know what? I'll take it as a typo. Because on a test, I'm almost definitely going to ask you to simplify something like this. So if somebody needed typo bonus, somebody's already on it. Nice. Yeah.
So you find them? We weren't after them?
Well, I often point them out in class, but since they're so abundant, you're probably able to find a lot more than the ones I point out in class. Negative sign times negative sign is what? Negative sign x squared. Cosine times cosine, that's cosine squared. I'm going to rewrite this as cosine squared x minus sine squared x. Which is equivalent to what? Cosine 2x. Very good. All right, so a very simple answer.
Wait, you explained that last step that you did.
Rule.
Rule. Got it.
Double angle rule for cosine. Algebra 2 pre-calc.
Could you leave it as the first thing though? Oh, the and simplify.
Yeah,
Okay.
the adjustment, yeah. All right, so that was the product rule. The quotient rule, you guessed it, applies when you have a quotient of two functions. All right? Now, that's, I think, easier to recognize because if there's a fraction in there, it's probably going to be a quotient rule situation. Right now, one thing to consider is sometimes you could algebra 2 your way out of it, which is to say factor, simplify, and maybe your fraction becomes not a fraction anymore. So be on the lookout for something like that on a test. But really, it's just a matter once you, I mean, if you don't have to simplify, it doesn't matter. But it's just a matter of identifying your denominator and your numerator and just following the process. All right, so you have the mathematical notation there. G of x times f prime of x minus f of x times g prime of x over g of x squared. That's all good. I learned it when I was a student. It said, we had to memorize the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator over the denominator squared. So that was something that we had to repeat over and over and over again until we all got it, and that was the end of it. Right. Then I became a teacher, and everybody has a mnemonic device for everything, and so somebody told me this one: low d high minus high d low over denominator squared, and away we go. Yeah, if you like it, cool. If you don't, then all right. The low part represents the denominator. The D stands for derivative. So low times the derivative of the high minus high times the derivative of the low. All right, so low d high, denominator times the derivative of the numerator. All right, order matters here. With product rule, order does not matter. But for quotient rule, it absolutely does matter because subtraction is not a commutative operation. All right, so I'm just going to follow a similar structure to what I did in the previous mini lesson, the product rule. Low d high minus high d low. And that's all over the denominator squared. And away we go, apparently. So low is 2x minus 7. Can't forget it. There's no rhyme without the away we go. And let it snow, or something, as long as it ends with the O, So, what's the derivative of the high? 2x minus high, x squared plus 2. D low, derivative of the low? 2 over the low squared. over denominator squared. 2x minus 7, quantity squared. Again, did not ask us to simplify. All right, there'll be plenty of situations later in the course where you will naturally want to simplify derivatives, just because we're going to be using it for something. Until we get there, there's no point. So without any kind of rationale as to why we're doing this, there's no need to simplify unless you're directly asked to. All right, so low x squared minus 1. What's my d high? 3x squared plus 3. Good. Minus high, so that whole trinomial.
Man, this low D high D low thing actually works.
It sure does. D low is 2x over denominator squared, x squared minus 1. All right. I'm going to throw in a little side example here. We'll call it, we'll call it a new example 5. I'm sorry, new example 6, and then 6 will become 7. So, but for now, I mean, I'll just make it 7, but I'll do it at number 6. Let's say I wanted to find the derivative of the tangent of x. All right, I'm stealing my own thunder a little bit because we get to this in another lesson, but I wanted to actually get to it now because I think it's kind of a, yeah, sine over cosine. All right, so that new problem, derivative with respect to x of tangent of x. Tangent is the same as sine over cosine. So what did not look like a quotient rule situation was now made into a quotient rule situation. Now we do our low d high d low, denominator squared, and away we go. So this stuff will actually be so second nature that there won't really be much need to study it. And that's kind of the point of all of this stuff. You do the practice in class, the discovery in class, so that the studying is kind of kept to a minimum. That being said, the people who screw this up, they just get the rhyme backwards. Instead of low d high minus high d low, it's high d low minus low d high for some reason on a test. So the order does matter. So low is cosine of x. What's my d high? Cosine of x again. Minus high, sine of x. Negative sine of x. Over the denominator squared, so cosine of x as a quantity squared.
Mr. Can we do 6?
We will. Yeah. So cosine squared x plus sine squared x over cosine squared x. Now what is cosine squared x plus sine squared x? 1. And what is 1 over cosine squared x equivalent to? Secant squared x. Now, I don't know if you remember, but as you were reviewing pages 1 to 3, one of those rules was that the derivative of tangent is equal to secant squared x. All right. Also, we did this with the limit definition back in the last unit, and it was a nightmare. I mean, it took up like I mean, I'm generously saying a quarter of a page. That's because you had to really write small. And in most cases, it took up a lot more than that. It's just I could zoom the living daylights out of it, so it was fine. But it took up a lot of space. All right, this, there's still a few steps to it, but it's much, much simpler. So if you're in a jam and you have to figure out the derivative of any of the reciprocal functions, so not even just tangent, maybe secant, cosecant, cotangent, you could now use the quotient rule to do that. All right, and it's going to be a lot easier. All right, but let's take a look at this puppy right here. So my first move is to erase that mark. See, I've always been like a man of few words. Like I kind of speak when it's necessary to speak. So it's always surprising to me that somebody can talk nonstop, like for an entire period. Like it's just like it's like start at the bell and then just not stop. It's just crazy.
It's an acquired talent.
It has to be. I mean, I don't even think I have the vocabulary for that.
I do.
I
could filibuster.
Yeah, I don't doubt that. But it is fascinating. So anyway, we have 2 times the natural log of x. All right, I made that small adjustment here prior to getting involved in the derivative process, just because I know at some point I'm going to have to take the derivative of that bottom term. And by writing it as 2 times the natural log of x, it's going to be a lot easier to do that. All right, so it's just a kind of a sight recognition that happens off the bat. All right, so poor quality line. Do it that way. So low D high. So again, let me get my low and my high identified properly. You don't have to use highlighters, but obviously for instruction it does serve a purpose. So low D high minus high D low. And I am incapable of drawing a fraction bar of the appropriate length for some reason. There it is. Over denominator squared. Now, little tip, maybe put your denominator squared in first. I know the rhyme has it coming last, but I'll tell you that from experience, when people screw this up, they screw it up because of the high D low, low D high switcheroo, but they also screw it up because they just flat out forget the denominator. I think it might be an not instructional. I don't want to take the heat on that. Maybe it is. Maybe it could be because I go over it this one time and I let you practice it, and maybe I could go over an example or two before it's all over. Maybe that'll help. But and I'll try to do that this time. But I think it could be just like a studying thing, because what'll happen is people become very, very well versed in the product rule. And so they're like, well, the quotient rule is just like the opposite of that. So they'll do the product rule with a minus sign in it because they didn't really study the quotient rule. Because there's enough situations where you can manipulate a function so that a quotient rule becomes a product rule type situation just by making negative exponents, that people will say, well, I'll just use the product rule all the time. And then they come across situations where they don't have a choice and they get caught up in a jam. All right, so I'll try to do a little bit more than I've done in the past, but you're also going to have to do your part in terms of studying. All right, so low 2 ln of x, d high. So for exponential e, we rewrite e to the sine of x, but then we multiply by the derivative of the exponent, which is what? Cosine of x. Hopefully we're at the point now where we're very comfortable with the derivatives of sine and cosine. The other trig functions maybe, okay, not quite there. Like when I said the derivative of tangent, you looked at that in pages 1 to 3 and you saw that it was equal to secant squared. You might have had a thought like, yeah, I'm sure I saw it. That doesn't mean I know it. Eventually you'll know it, right? But sine having a derivative of cosine and cosine having a derivative of negative sine, that should be more instantaneous at this point. Minus high, e to the sine x, d low. All right, so derivative of 2 times the natural log of x is what? 2 over x. All right, if you want, you could write it as 2 times 1 over x. All right, either way, because we're not going to simplify this anyway. If we were to simplify it, the best we could do would be to pull out an e to the sine of x, but that it wouldn't clean up any further than that. So this is not something I'd ask you to do anything more than what we just did. Right? So a lot of what we're going to be doing, at least for the foreseeable future, is just working on the skill of taking a derivative using different techniques. All right? Once you have those skills down, then we'll start getting into, okay, now what are we using this for? All right? So for now, it's just skill-based. All right, so your practice is on page 24. All right, so if you kick over to that, you can see a bunch of product and quotient rules.